Everyone, today we are going to talk about trie in data structures. Okay, so what is a trie? A trie is a tree, and the advantage of a trie is that searching of a word becomes very easy in trie. Okay, and its worst case time complexity is O of m, where m is the key. Where, for example, a key is A is a key, S is a key, O again A is a key over here. So O of m. So let's see how. Okay, let's search for ASAP. For example, okay. So I search for the key A. It exists. Okay, I move on and search for S, and then it exists, therefore I search for A, and finally I find the letter P, so therefore my word exists. Now let's say I am trying to find the word ASAQ. So I'll search for A, it exists, then S exists, then A, it exists, and then finally Q. But since it doesn't exist, so it returns false. Therefore, uh, my word doesn't exist. Okay, let's search for the word Q, Queue. So in the beginning it searches for the letter Q and it couldn't find it. So therefore in the beginning only my tree returns false, therefore I know that the word doesn't exist. So as you can see, it entirely dependent on whether a particular key exists or not. So therefore time complexity is O of m, where m is a key. Okay, now let's see how do we do it. So we are going to use the map function which was recently introduced in JavaScript. Okay, so a map function returns an object in key value pairs. Okay, so what is a key value pair? So let's say data equals A colon B colon C. Okay, here A is the key and this object is my value. Again, B is the key and C is my value. Okay, so this is a key value pair and it has two functions associated with it. One is a get function which is used to retrieve a key, and a set function which is used to add a key value pair to my object. Okay, so let's create a node. Okay, class node constructor this dot key. Okay, is new map. Okay, so this dot key is basically this, these are my keys. Okay, so this dot key is new map. Now this dot end equals false. Initially this dot end is false. This dot end says whether it's the ending of a word or not. Okay, here star denotes the ending of a word. Okay, so this dot end equals false. This dot is end is a function which returns the value this dot end. Okay, this function will return the value this dot end, and this dot set end, what it does is sets this dot end to true, this dot end to true. Okay, so this is my node. Okay, now let's create the class trie. constructor, initially my class contains a root node. So therefore this dot root equals new node. Okay. Add function. Now this function is used to add values to my trie. Okay. So it will take two parameters. One is an input parameter and the other is an optional parameter which is node. Okay, input, and another is an optional parameter node this dot root. What will it do? Okay, now initially if input dot length equals 0, if initially the length is 0, then it will set the value of end to true. So therefore node dot end set end is equal to true. Node dot set end will set this dot end to true and return. I'll return from the function. Okay. So initially when the length of the string is 0, so it will set it as true, which means I have reached the end of the word, and then I'll return from the function. Now else, if my word is not of length 0, then what will I do? If. Now as you can see, at first we will check whether a key exists or not. For example, let's take up this example. When we add bad, I'll go and check whether the key B exists or not. Okay, so I'll check that if node dot key dot get, node dot key dot get or node dot key dot has, if the key exists, node dot key dot input dot char at 0. So if the character B exists in the node, then what will I do? Then I'll traverse inside B. Okay, if this key exists, then I'll traverse inside B and then I'll move on. Okay, so I'll traverse inside B and then I'll move on. So my new node will be return this dot add. So I'll again call the function add, but now with the value as AD, because I have found out that B already exists. So I'll see whether A exists or not. Okay, so this dot add input dot substring 1. Okay, so whether substring of 1, what it does is cuts the string from BAD to AD. Okay, okay, so and now my new node value will be node dot key dot get. Now I will use the get function to get or retrieve the key and value. Okay, node dot key dot get input dot char at 0, whether this key exists or not. So I'll get this particular tree now. Okay, if it doesn't exist, say node dot key dot has input dot char at 0 is false, which means my character doesn't exist. For example, when it traverses to B, it couldn't find a character named A. Okay, so what it does is it creates a new node with the name A. Okay, so node dot key dot set. Set is used to create a key value pair. So it creates a new key, which is input dot char at 0 and new node. It creates a new node. Okay. Now what will I do is do the same thing. I have created a new node A. Now I will traverse inside that node. Okay. So it does the same thing, and then it again goes and searches for D inside A. It couldn't find D, so it creates a new node named D, and then I'll return the string null. So since it returns null, so what does null do? Node dot setting. So this is the ending of my string or my word. Okay. Now another functionality is word. So what it does is it checks whether a particular word which is input, it exists in my tree or not. Okay. So let node equals this dot root. Initially it is the root node. Okay. Initially my node is the root node. So I will now check whether the particular input string exists in my root node, exists in my tree or not. Okay. So while input dot length is greater than 0, I'll continue this loop till my till the length of my input is 0. Okay. If node dot key dot has, okay, now what I am doing over here is, let's see, if it doesn't have a particular key, then it should return false. Okay. So if not not of node dot key dot has, which means if my particular key doesn't exist, it returns false. Which means that it doesn't exist. The word doesn't exist. Else, what will I do? Else, uh, now let's search for ASAP. Okay. I look for A, I find A. Okay. Now what will I do is traverse inside A. Okay. So node equals node dot key dot get input dot char at 0. Okay. Now I will traverse inside this. Okay. And I'll shorten the input string by 1. So input equals to input dot substring 1. Okay. Now what it does is it searches for S. Since S exists, so it traverses inside S, and then again I shorten the string to AP. Okay. So it continues to do like this till it doesn't find a particular key. When it couldn't find a particular key, it returns false. If I reach the end of the string, that means that particular word exists. So I will return true. Okay. So this is the is word functionality. Okay. So let's see now. Let ob equals new try. Create an object. Now ob dot add, what will I add? Boy. then I'll add pad, and then I'll add ASAP. Now let's see whether it exists or not. Console.log ob.isWord boy. Let's see what happens. Okay, you see it returns true, which means the word boy exists. Okay, let's say bat, false, which means the word doesn't exist, bat. Okay, ASAP, you see it returns true, ASAQ. Okay, false. Now let's add ASAQ again. ob.add ASAQ. Now I am again searching for this one. Let's see what happens. Okay, you see at first it's false because initially ASAQ doesn't exist. Then I add ASAQ to my tree. Then it says that it is true. It returns true, which means ASAQ exists. Okay. So as you can see, searching is quite easier, and searching depends entirely on whether that particular key exists or not. So my time complexity becomes O of m, where m is that particular key. So it helps us to search words very easily, and try stores the words in a dictionary manner. As you can see, it stores them alphabetically. So in this way we can add more values to the tree and search for them. So hope you like it. Thank you.